Okay, so we're looking at exponential and logarithmic modeling, and usually time is the independent variable, so it goes on the x-axis and something else goes on the y. So we could have base e, or we could have a base some other number. So you can have basically the first part being the initial value, that's when t equals 0. And if k is greater than 0, then it means it's continuously growing, going up with time. And if k is less than 0, then it's falling with time. And examples of continuous growth would be compound interest, when you save in the bank and you don't touch it, or bacterial growth, and continuous decay could be radioactive decay or falling populations. Here's our example. Your decay of technetium-99, which is used in medical treatments for cancer usually, can be modelled by the equation A equals A0 times e to the power of kt, where t is in hours and A is the amount of technetium-99 remaining, and that's in grams. I should have put it in there. The number of remaining atoms of technetium-99 is reducing by 11% every hour, and there are 1,000 grams of technetium-99 remaining at t equals 0 hours. Now, to start with, you have to write down what you're given. So we're given that it reduces by 11% every hour, and that we start with 1,000 grams of technetium when t is 0. And that actually means that A0 is 1,000. So we'll keep that. So we've got what we have from before. It's reducing by 11% each hour, and A0 was 1,000. How many grams of technetium will remain after 1 hour? Well, if you know it's reducing by 11%, that means the amount remaining is 100 remaining. That's not what we're about. Right, so remaining is 100 take away 11%, which is 89%. We'll put the percentages in. So what's remaining after 1 hour is 89 over 100, which is 89%, times 1,000 grams, which works out to be 890 grams. If you like to see the cancelling, these cancel, those cancel, and that gives me 89 times 10. Now to find k correct to 4 decimal places, you need to use the previous information. That was when t equals 1 hour, we had 890 remaining remaining grams of technetium. So what you do is you plug in to the equation 890 equals 1,000 e to the power of k, and t is 1. So this is where they're from. A was 890. A0 was always 1,000 from before. E was there already. K we're trying to find out, and 1 was the t value. So then we proceed to solve for k. So our first step is to divide by 1,000, which gives you 0.89 equals e to the power of k. And then you take logs of both sides, and if it's a natural log, we can write ln of 0.89 equals k. It's correct to 4 decimal places, so you need to use your calculator for this step. And so that would give you k is approximately equal to 0.1155 with a negative in front of it. Now, just to check, that number is smaller than 1, so we do expect a negative answer for the log of it. So from before we had k is equal to negative 0.1155. So to write the equation, it should be very straightforward. You write A equals A0, which is 1,000, e to the power of k, which is negative 0.1155, and we put the t in there. Right, so physics people will be familiar with half-lives. Basically that's a time that it takes to go from the original amount to half of that amount. So what we're finding is we are finding t when A is 500. So we would put 500 equals 1000 e to the minus 0.1155t. And then you have to divide by 1000, which gives you 0.5 equals e to the negative 0.1155t. And we'll take logs of both sides, so log to the base e is a natural log, or ln, of 0.5 equals negative 0.1155t. Okay. So from before we had natural log of 0.5 equaling negative 0.1155t. The next step is to divide by the coefficient of t, so you'd get t equals log of half, or 0.5, either way is fine, divided by this coefficient here, which is negative 0.1155. You do need your calculator for this, and it's approximately 6.02, and so you'd round it off to the nearest hour, so it's 6 hours. And last but not least, how long means find the time for which the mass of technetium-99 will be reduced to 100. So again, we solve for t when a is 100. 100 equals 1000 e to the negative 0.1155t. And it's virtually the same steps as before. We divide by 1000, and then we take logs of both sides, and then we divide by the coefficient of t. So rather than do that all again, which is in your notes anyway, we'll just do it the way you do it on a calculator. All you do is you write solve for t, and then t will equal to 19.935, which is approximately 20. And what you type in your calculator is solve, and then you type in this equation here, which would look like this: 100 equals 1000 e to the negative 0.1155t, and you make it solve for t, which means you have to write t here. And when you hit enter, it'll give you this answer here, and then you round it off to a whole number.